Hello, so today we are going to talk about a two-sided significance test. So make sure you watch how to conduct a significance test before you watch this video. This is the second type of significance test that we're going to talk about regarding the alternative hypothesis. So this is section 9.2 in your textbook. Please go there to look at extra examples, and your one homework problem corresponding to this section is there. So let's review how to conduct a significance test. We have the four-step process. We should be really familiar with these 4 steps by now because they're the same steps for every test. So, first step is to state the population parameter and then my 2 hypotheses. And today, the alternative is going to be what changes. Step 2 is the plan. We need to check that it's a random sample. It's a normal sampling distribution, so my sample's large enough to be normal, and then independence. So my sample's small enough compared to the population, and I want to make sure that each sample, or each thing in my sample, I should say, is independent from the other. The do step is where I actually do the substitution and I do the calculations to find the p-value. And then the 4th step is where I conclude. So just to make sure that we all know, these 3 C's stand for conclude, connect, and context. The conclusion is where I reject or fail to reject. So it's what I conclude based on my p-value. The connection is where I write my p-value, or I have the p-value in my conclusion. And then context is when I reference the problem. Or I reference the parameter. So those are my 3 C's of the conclusion or the interpretation. So let's take a look at the example we're working with today. This example comes to you especially from my sister who lives in Hawaii. So it says Hawaiians have been known to be skeptical about the use of genetic engineering to improve foods, aka foods with GMOs. A random sample gathered responses from 150 Hawaiians. Subjects were asked if they disapproved using modern biotechnology in the production of foods. In all, 116 Hawaiians disapproved in GMOs. According to a recent Gallup poll, the population proportion for all Americans who disapproved was 65%. So it says, do these results provide convincing evidence that people in Hawaii differ from the national average? Support your conclusion with a test of significance of alpha equals 0.05. So this is a lot of words. This is a big problem, only to ask us to do a test of significance. So even if it just asks for a test of significance, you must do all 4 steps. You have to do state, plan, do, conclude. You can't just do your calculations or say what you think. You have to go through the 4 steps. So we're going to start with step 1, which is the state step. So if I think about the population, or the WHO, it talks about the population of all Americans. But if I think about the population that I took my sample from, it would be all Hawaiians. The parameter, or what I'm measuring about those Hawaiians, is the percent who disapprove in using modern biotechnology in the production of foods, or we want to test a claim about the, think about it, is it a percent or an average? About the percent, because it's 116 out of 150, who disapprove in GMOs. So that's my parameter. For my hypotheses, I always compare to the population proportion. So the population proportion is where I get the claim. So the national claim is 65% of people agree disapprove of using GMOs. So the null hypothesis is that the true proportion equals 0.65. But we want to test the claim to see what percent differ from 0.65. So this differ came from the first slide. It said we want to test the claim about those who differ. It's not on this page, but it was on the first page. It said differ. So differ means not equal to, and we want to test the claim that the true proportion is different or not equal to 0.65. So key point number 1, for a two-tailed test, our alternative hypothesis is that P is not equal to the given parameter. Or it's going to say that it's different than or differs from, something along those lines. So if we think about a two-tailed test, that means it could be below or above my two different critical values. So I have two endpoints. I have the lower endpoint, or the negative critical value, and then the upper endpoint, or the positive critical value. So if I keep going with my test, step 2 is my plan. First condition is random. Well, if I look back in my problem, it says we had a random sample of 150 Hawaiians. So it's stated that it's random. Check. The second condition is normal. Well, since this is proportions, how I check normality is NP greater than or equal to 10, and the sample times 1 minus the claim proportion is greater than or equal to 10. This is to make sure my sample's large enough. And if I do that arithmetic, 150 times 0.65, remember 0.65 is my claim, greater than or equal to 10, well, that gives me 97.5, which is greater than or equal to 10. But I have to check the other one. 150 times 1 minus 0.65, or times 0.35, greater than or equal to 10. That gives me 52.5, greater than or equal to 10. Check. So I know it's random. I know it's a normal sampling distribution. And independent, we're going to assume they're independent people. So we're assuming they're independent people who I'm interviewing. I'll go ahead and mark the independence one is down here. And we're going to assume that the population of Hawaiians is more than 10 times 150, or the population of Hawaiians is more than 1,500. And if you think about all the people on Hawaii, that condition makes sense. So now I get to the do step, and this is very similar to the first video, but there's going to be one little difference. So let's write out my knowns real quick. I know that P equals 0.65. I know that N, or my sample size, is 150. And then I'm missing one part of my formula. I still need to find P hat. Well, P hat comes from the number who met the characteristic of interest divided by the sample size, or 116 out of 150, and that gives me 0.77. So I have P hat, N, and P. When I plug those into my critical value formula, I get Z equals 0.77 minus 0.65 over the square root of 0.65 times 1 minus 0.65 over 150. So make sure that in the denominator you use P, or you use the claim value, not P hat. Well, when I do that arithmetic, I'm going to get 0.12 divided by 0.0389. And when I do that arithmetic, I get that Z equals 3.08. So if I draw my normal curve, because we said it's a normal sampling distribution, you should be really comfortable with these curves by now. We've been doing them a lot this year. So if I have my normal curve, and if I think about where this z is, this z would be up here at 3.08, and usually I would just shade above that z. But this was a two-tailed test. Think about my alternative hypothesis was that p is not equal to 0.65, which means I also have to do negative 3.08, or shade below negative 3.08. A two-tailed test means I have two tails of my normal curve that are shaded. Well, if I look at my z table, the area down here, my p, or the probability of being down there, is 0.0010, and the probability of being up here is 0.0010. Well, if I have two shaded areas, if I have the area down here and the area up here, my final p-value is adding those two areas together, because the probability I'm in both of these areas counts as my p-value. Both of these are shaded. My p-value accounts for both of those, so my p-value is 0.002. So key point number 2, for a two-tailed test, we must look at the area above the positive z and the area below the negative z. And I add these two areas together to get my final p-value. So if I think about my conclusion, it asked me to support my conclusion with an alpha equals 0.05. And this template right here, this is the same template that we've been using in class and in these videos. If you write it like this every single time, you're going to get really comfortable with this, and the more comfortable you get with this, the more likely you are to write the conclusion correct on your test and on the AP exam, which is the ultimate goal. So since the p-value is less than alpha, oops, I need the marker for this, because p was 0.002, and that's less than 0.05. So since the p-value is less than alpha, I can reject the null hypothesis claim that the true, well, think about what we were testing. We were testing the true proportion of all Hawaiians who disapprove of using GMOs or modern biotechnology in food. So all I do is restate this down here so that the true proportion of Hawaiians who disapprove in GMOs is equal to, and this is where I restate the 0.65, or the claim that was given to me in the problem. So let's just say this together. Since the p-value is less than alpha, my p-value, or the area under the curve, is less than my alpha value, we can reject the null hypothesis claim that the true proportion who disapprove in using modern biotechnology or who disapprove of using GMOs is equal to the claimed value of 0.65. Once again, key point number 3 is this template. You should be really familiar with this and getting really good at writing your conclusions. And that's a wrap. If a test is two-tailed or not equal to in the null in the alternative hypothesis, we multiply the one-tailed p-value by 2, or we add the area below and the area above the z-values together. This is section 9.2. Please go there to look at extra examples, and that's a wrap.